Okay, since this is a voluntary Zoom kind of environment, I wanted to do the second half of the PowerPoints that I put up the other day, so we can continue working on this forecasting piece. Again, the integration of this will show soon, but we're going to be using this for Betty's bats. There are going to be three parts to it. I mentioned this the other day. There's going to be the part which is a forecasting piece. There's going to be a part which is the critical path method piece. And then there's going to be the optimization piece. So today, let's see if we can share screen and try to, there we go, and try to get to the second part of what we were talking about in the other session. So just give me a minute here. Clear some of the nonsense off the screen here. And let's just go down to where we left off, which was we ended up talking about, there we go. Excuse me, ended up talking about some of the simpler techniques in forecasting. Why would we be forecasting and so forth? And it was the idea of using simple moving averages, 3-period moving average, 3-period weighted moving average, 5-period moving average, and so forth. And it got us to the point of something that now becomes a little bit more tedious. None of the stuff that we're doing is hard as such. It's not hard. It's a little bit tedious. It's a little bit repetitive. So if you're like me and your Rain Man kind of sets in after a while, then you sit back and say, oh geez, okay, I got to do this again and again. And in truth, yeah, that's part of it. And you're just going to have to jump through the hoops on it. So we pick up today with the idea of exponential smoothing. Now, we talked a little bit about the idea of a weighted moving average. And we said the underlying theory was that we weight more recent data more heavily, so that we're trying to take into account most new information introduced into the environment. And environment, we don't mean the bug and butterfly commission stuff. Environment, we speak to the environment, we mean economic, technical, cultural, social, regulatory, political, legal. You get the idea. So when we talk about exponential smoothing, it is the idea that we want to weight or put emphasis on either the demand side of the equation or the forecasting side of the equation, perhaps in similar amounts, perhaps in completely dissimilar amounts. It's almost the sense of, what do we believe more? What do we think is going to be more accurate? And think about the first couple of things we spoke of, and we had trying to forecast that next period, November. We had several different results. We had 110 with the 3-month moving average. We had, I think it was 91 with the 5-month moving average. And then we had, I think it was 103.4, or maybe it was 104.3, whatever it was, for the weighted moving average. And we said, well, gee, which one is correct? And the answer is they're all correct, just a different technique. And the question ensues, well, which should I rely on? And when we start talking about a reliance, obviously we can do simple things. So if I were going into a meeting and somebody said, oh geez, look, we're going to be asked what the forecast is, what we think we're going to do next month. And if I get hit with this walking into a meeting, well, probably the easiest thing, because again, do a little bit of arithmetic in our head. I can probably do this averaging thing, sum divided by number. I can do that in my head. So I probably would use a moving average of some sort. Well, if I've got time to prep and, it's a bit more of an involved meeting and the answer needs to be a little bit more, let's call it robust. Well, then it might well be that I do something a little bit differently. I might rely on a technique that's a little bit more robust in itself. And that's where we start to get into this idea of like exponential smoothing. So I know some of us are going to look at this and they're going to say, "Oh, God, I suck at math. What does that mean?" Breathe. Easy, easy. It's okay. It's okay. This is not about math and complicated formulas. It's about trying to see what we're looking at, what we're being asked. So, for example, and you'll appreciate, the cleverness, which of course sarcastically I mean it. So it's really the lack of cleverness in this, but you'll appreciate the cleverness in this. So look at what it's saying here. F. Oh, what can F mean? F, in the context of what we're speaking of, is forecast. Oh, okay. Well, then what's the D? Well, we've been talking about a couple of different things. We've been talking about forecasts. We've been talking about demand data. D, demand. D is demand. Then we've got this funny little thing here, which you and I recognize as, alpha, if you will. And, that's going to be our kind of, let's call it a weighting factor here. Well, then what's all this small stuff under here? All right. Okay. Fair question. If I wanted to speak, certainly in one way, about something happening in the instant, what does that mean? In the instant, meaning now. For example, the forecast now, the forecast of the instant. Thinking of that in terms of time, well, it would be the forecast at the present time. How do I express that? Well, if you look back here, it says F sub t, the forecast at, in essence, time zero, but the forecast in the instant, the forecast of now. Well, if that's the forecast for now, then t plus 1 would seem to indicate the forecast for the next period. F sub t is now, F sub t plus 1 is the next period. Well, what does that mean? Well, it means that if my periods that we're speaking of are weeks, then this would be this week, t plus 1 would be next week. If the period is monthly, as in our continuing example, then F sub t would be this month's forecast. F sub t plus 1 would be the next period's forecast. Okay. So I'm trying now to see that to get, is what this seems to say to me, to get the forecast for the next period, I have to take alpha, this, let's call it a weighting factor, multiply it by d sub t, in other words, the now period, the current period, but the demand for the current period, plus 1 minus alpha. It's kind of like almost the reciprocal of alpha. So we'll see in a minute how that plays. But so alpha times the current demand plus 1 minus alpha times the current forecast. Okay. Everything we know has to be between 0 and 1, or 0 and 100%, if you will, and you can spend time looking at that. So that if we take this example and we see that we have periods from 1 through 12, which are January through December, and again, we have the actual demand data of everything from January through December. And again, it doesn't matter what these things are, 37 what? I don't know, 37 cars, 37 houses, 37 MRI machines, 37 open heart surgeries, if it were a service versus, a product of something, whatever it is. We already know, because we discussed it, that the demand numbers come at the end of the period. I know what we did in January at the end of January. I know what we did in February at the end of February. I know what we did in March, at the end of March, and so forth. But what we're trying to do is forecast. We spoke about this: forecast, guess, prophesy, you get the idea. The next period. Well, if December is the last period I have demand data for, the next period is next year's January. So the next January, the 13th period. That's what I'm trying to forecast. And so what we're saying here is we're going to use this idea of exponential smoothing to generate this forecast for us. Now here's where it gets a little tedious. And this is going to be, and I don't give homework per se. So this is not, in quotes, homework. But I am tasking you to do this at home. I'll explain it. We'll go through it. I'm tasking you to physically do it. It's not homework because you're not handing it in to me. Because at the end of the day, I already know this stuff. I'm tasking you to do this for you because it's a good technique. And I think it would be a real asset and a tool in your belt to be able to use this if and when it comes up, instead of just making arbitrary determinations. But that's another convo. So remember up here, we did t plus 1, f sub t plus 1. Well, what we're doing here is we're actually identifying the periods. Now, realize what we need to make this equation work. We need the demand data from period 1. Do I have that? Yeah. Period 1, demand 37. Got it. Do I need the forecast data for period 1? Yeah. Uh-oh. I ain't got it. I don't have it. I don't have forecast. Why? Well, because that would be data back up here somewhere. And that's not provided. So in this first calculation, I am going to use the demand data in both locations. Now, those of you that are better than me at math already know that over here, I've got a weighting factor called alpha. And over on this side, I've got a weighting factor 1 minus alpha. So I'm going to, in essence, weight the current demand and add to that the reciprocal of the weighting factor for the current forecast. And remember, we said that everything has to be between 0 and 1, or 0 and 100%, if that's easier for you to understand. Already looking at this, a portion of this plus the reciprocal, a portion of that equals 100%. So if I'm using 37, the demand data in both locations, just looking at this, I already know the outcome. It's 37. But let's go through the steps anyway. We are going to arbitrarily, remember I gave you the discussion on random. No, this is not random. This is arbitrary. We're arbitrarily picking a weighting factor for alpha of, let's call it 30%, which means that 1 minus alpha, 1 minus 0.30 is what? 0.70. 30%, 70%. I'm underweighting the demand, arguably overweighting the forecast. Okay. The demand number is 37. And since I don't have previous data, I'm using the demand number for the forecast number as well. So again, in the words of Robert De Niro, Do the math. 30% times 37 plus 70% times 37 equals, you guessed it, 37. So we are now starting our column of forecasts here. So our forecast for period 2 is February. Our forecast, and remember, we're doing this at the end of January. So at the end of January, our forecast for period 2 is 37. Now, since we already have the demand data, we already know what the outcome is, but we didn't know that until the end of February. All right, so let's continue down and let's create this column of forecasts. I'm going to help you with the first two, and your tasking is to do the rest of them to enable us, because if you see, it's kind of a build as we go forward, to enable us to generate this 13th period forecast, which would go somewhere here. So we did period 2. Let's do period 3, the forecast for period 3. Again, alpha is 30%. So in essence, the reciprocal of alpha is 70%. And what does it say? It says 30% times the demand for period 2. What's the demand for period 2? It's 40. 40. 40. 40. 30% times 40 plus reciprocal of alpha, 70% times the forecast for period 2. Well, we just did that. We just came up with the forecast for period 2, 37, 37, 37, 37. 30% times 40 plus 70% times 37. Do the math. The forecast for period 3 is 37.9. So that would go over here in the column we're creating. So at the end of period 2, we're trying to forecast period 3, and we come up with a number of 37.9. Well, at the end of period 3, we will come to learn that the actual demand turned out to be 41. Again, close. The demand and forecast numbers close, but no cigar. Okay, so now we have to forecast period 4, and you would just index everything down. So your tasking is to do forecast for period 4, period 5, period 6, period 7, etc., until you get down to the bottom, which is the forecast for period 13. Why you can't just skip all that's in between? Well, because for period 13, for the forecast for period 13, you need the demand data for period 12, which we have here. But you also need the forecast data for period 12, which we don't have. You get the forecast for period 12 by forecasting period 11. You get 11 by forecast, and so on and so forth. I'm sure you see this by now. But here's the bottom line. So when we finally go through all this tedious stuff, remember I said it's not heavy math, a little bit of multiplication, a little bit of addition. That's all we're doing. But it's tedious. So by the time you get through all of these things, when you get down to the bottom, the forecast for the 13th period turns out to be 51.79. When will we know what the demand number is for that next January? At the end of January. So let's take this. Again, using alpha as 30%. If we follow what we were just discussing all the way down, these are the forecast numbers all the way down. So you don't have to actually hang on just 1 second. Let me just mute this I'm not going to be able to, well, let me see if I can mute this. I'm not going to be able to mute this, so hang on just a second. Give me 5 minutes. All right, sorry for the interruption. Anyway, so using an alpha of 30%, we get all of these forecasts all the way down. So an alpha of 30%. Now, stop and look for a minute. So 30% of the demand means 70% of the forecast. So in terms of weighting, what's actually going on? Well, in terms of weighting, we're underweighting the demand and overweighting the forecast. Do we have to do it that way? No. Instead of an alpha of 30%, we can equally weight the demand and forecast, an alpha of 50%, because if alpha is 50%, 1 minus alpha is what? 50%. We can reverse exactly what we're doing here and 70% weight the demand, 30% the forecast. And this is where some of the underlying theories come into play. And for this course, it's not essential we understand all of that, other than we need to be able to manipulate the data here. But if we were to equally weight, do the demand number at 50%. So 50% times the current demand, 50% times the current forecast. You'll see how that affects our forecast. Which would be correct? They're both correct. So again, we have reliance on other things. And when we look at exponentially smooth forecasts, coefficient, if you will, of alpha, 50%, 30%, you can see the difference. But we start to, again, attenuate some of the noise, and we start to identify kind of an underlying trend. Okay, of course, excuse me, if there's an exponentially smooth forecast, of course, there's an adjusted exponentially smooth forecast. Adjusted by what? Well, exactly this. Adjusted by the underlying trend. So the formula for adjusted exponential smoothing, the adjusted exponentially smooth forecast for the next period, t plus 1, is the forecast for the next period. And go back here, we just learned how to do that. That's all this stuff. So we learned how to generate those forecasts. So it's the forecast for the next period, only now we're going to add to that forecast the underlying, geez, I hope to be over this stuff soon. I apologize again. We add to that the underlying trend, be it a positive trend, presumably, or a negative trend, whatever. So T is an exponentially smoothed trend factor. And we get that trend by introducing something called beta. Now, we will remember with fondness, I'm certain, when we took the stats course and so forth, we learned about alpha and beta, intercept and slope. Okay, remember that stuff? Remember hearing about that? All right, so right now that's not going to mean anything to us, but it will soon. For right now, we're just going to suggest that we are arbitrarily choosing an alpha and arbitrarily choosing a beta. So much like getting the next period forecast, we're getting the next period trend, which is done by beta, this weighting, if you will, thing, this weighting factor, beta times the difference between f sub t and f t plus 1. In other words, the difference between the most recent forecast and the next most recent forecast. So if f sub t is 1, t plus 1 is 2. So the difference between the forecast at time 1 and time 2. So net the difference, multiply it times beta. Add to that 1 minus beta, and just like with alpha, if beta is 30, 1 minus beta is 70, you get the idea. So this net times beta plus the reciprocal of beta times the current trend. Current trend, t sub t. Next period trend, t sub t plus 1. It should all seem very familiar. Let's take the example. Now, the reason the first one we can do is period 3 is because remember when you had a vertical and a horizontal axis, XY axis, and if we had an intercept and put a point out in space, if we had an intercept and put a point out in space, All right, well, it's not quite a trend. We could actually call it that because we have 2 points to connect, 2 dots to connect. But in the absence of that, if we just put a point out in space, in this XY continuum, if we just hung a point out there, could we determine a trend from that? And of course, we know the answer is no. So we need 2 periods of prior data to be able to do that. And so that's why we're starting at 3, T sub 3. Beta times the difference between the forecast at period 3 and the forecast at period 2. Well, where do we get that? Well, go back. We have all this. Forecast at period 3, forecast at period. We've got all that. So what we're trying to do, again, beta times the net of this plus the reciprocal of beta times the previous trend. Okay, so beta, if it's 30%, 1 minus beta is 70%. Forecast at period 3, we said was 38.5. It's right off the list there. Forecast at period 2, we said was 37, because remember we were, using the demand data twice, blah, 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 all this stuff. Okay, plus 70% times 0. Well, why 0? Well, again, think about the XY and think about the line we're trying to generate. So anyway, when we calculate T sub 3, it turns out to be 0.45. So to get the adjusted forecast for period 3, it's the forecast for period 3 plus the trend for period 3. So it's that 38.5 plus 0.45. So our adjusted exponentially smooth forecast is then 38.95. I'm not giving you homework, but I am tasking you to follow this all the way down to the 13th period. And you'll start to see that, look, we did the forecasts all the way down to the following January. We identified the trends all the way down to the following January. We identified the adjusted exponentially smooth forecasts all the way down to the next January. Well, so these are the numbers now. Which is right? Here again, they're both right. Different technique, one arguably more robust than the next. And you can step through and you can see the smoothing and so on and so forth. So the last thing we will do, which we are not doing in this session, but I will put up a separate one, is linear trend line. And if we remember linear regression, we'll find that to be very similar. So I'm going to stop share with this. And since I'm doing this really as a video, so to help you through the PowerPoints, there is no session here, so there are no questions to be asked. We will again try and meet on Friday at 6, and we'll see how that goes, because I still don't have too many returns as far as an alternate date or time. And again, it's a little bit like herding squirrels. And look, it's an online course. Nobody really wants to have to meet in Zoom, but you may find it helpful. So in any event, I'm going to end this here. And once this converts, I'm going to try and post this and send this out to you, so you have this piece to work with as well. Enjoy your day. We'll chat soon.